Assalamualaikum. I'm Ahmad Azman.
And I'm Ahmad Naik.
Trigonometry. Trigonometry is the branch of mathematics concerned with specific functions of angles and their application to calculation. There are 6 functions of angle commonly used in trigonometry. Their names and abbreviations are sine, cosine, tangent, cotangent, secant, and cosecant. These 6 trigonometry functions in relation to a right triangle are displayed in the figure. For example, the triangle contains an angle A, and the ratio of the side opposite to A and the side opposite to the right angle, the hypotenuse, is called the sine of A or sine A. The other trigonometry functions are defined similarly. These functions are properties of the angle A independent of the size of the triangle, and calculated value were tabulated for many angles before computers made trigonometry tables absolute. Trigonometric functions are used in obtaining unknown angles and distance from known or measured angles in geometric figure. Trigonometry development from a need to compute angles and distance in such field as astronomy, mapping, surveying, and artillery range finding. Problems involving angles and distance in one plane are covered in plane trigonometry. Applications to similar problems in more than one plane of 3-dimensional space are considered in spherical trigonometry.
Thank you, Ahmad Azlan. So, today I'll talk about the history of trigonometry. In the early study of triangles, it can be traced to the 2nd millennium before Christ. In Egyptian mathematics, Rhine mathematical papyrus, and Babylonian mathematics, systematic study of trigonometric functions began in Hellenistic mathematics, reaching India as a part of Hellenistic astronomy. Firstly, in Indian astronomy, the study of trigonometric functions flourished in the Gupta period, especially due to Aryabhata, 6th century CE, who discovered the sine function. The word trigonometry comes from the Greek word triangle, and the metron is to measure. Until about the 16th century, trigonometry was chiefly concerned with computing and the numerical values of the missing parts of a triangle, or any shape that can be dissected into triangles when the values of other parts were given. For example, if the lengths of 2 sides of a triangle and the measure of the enclosed angle are known, the third side of the 2 remaining angles can be calculated. Such calculations distinguish trigonometry from geometry, which mainly investigates qualitative relations. Of course, the distinction is not always absolute. The Pythagorean theorem, for the example, is a statement about length of the 3 sides in a right triangle and is the quantitative in nature. Still, in its original form, trigonometry was by and large an offspring of geometry. It was not until the 16th century that the two become separate branches of mathematics. Thank you. And now we'll move on to Mr. Bobby Wilson on about Islamic history of trigonometry. Bobby?
Thank you to Ahmad Naik. During the Middle Age, the study of trigo continued in Islamic mathematics by mathematicians such as Al-Khwarizmi and Abu al-Wafa. It became an independent discipline in the Islamic world where all 6 trigo functions were known. Muhammad ibn Musa al-Khwarizmi produced accurate sine and cosine tables, and the first table of the tangents. He was also a pioneer in spherical trigonometry. Also, Habash al-Hasid al-Mawazi produced the first table of cotangents. Muhammad ibn Jabil al-Harani al-Batani discovered the reciprocal function of secant and cosecant and produced the first table of cosecant for each degree from 1 degree to 90 degree. By the 10th century, in the work of Abu al-Wafa al-Buzjani, Muslim mathematicians were using all 6 trigonometry functions. Abu al-Wafa had signed table in 0.25 degree increments to 8 decimal place of accuracy and accurate table of tangent values. He also developed the following trigonometry formula, which is sin 2s equal to 2 sin x cos x, a special case of Ptolemaic angle. Also, Al-Jayani of Al-Andalus wrote the book of unknown arcs of a sphere, which is considered the first treatise on spherical trigonometry. The method of triangulation was first developed by Muslim mathematicians who applied it to practical use such as surveying and Islamic geography as described by Abu Rehan Biruni in the early 11th century. In late 11th century, Omar Khayyam solved cubic equation using approximate numerical solution. In the 15th century, Jamshid Al-Kashi provided the first explicit statement of the law of cosine in form suitable for triangulation. In France, the law of cosine is still referred to as the theorem of Al-Kashi. He also gave trigonometry tables of value to sine function to 4 sexagesimal digits equivalent to 8 decimal place for each 1 degree of argument with difference to be added for each 1/16 of 1 degree. So, that's all for the Islamic history of trigonometry. Thank you. Now we will show the special recording from our reporters interviewing the expertise in the field that involves trigo. Assalamualaikum and good evening. Trigo is widely used in aviation. So today we have another special guest, which is Captain Hakim. So we can go to.
Hi.
Hi, Captain.
Hi.
How are you?
I'm fine, thank you.
Yeah. So, as you know, trigo is widely used in aviation. So we will interview you about the trigo in aviation. So can you tell me more about aviation in the application of trigonometry?
Alright, first of all, thank you. So here we are in the heart of Malaysia Airline, which is the KLIA hangar. Okay, I'll briefly explain about the aviation itself. So aviation is a practical practical art of aeronautics. So it's being designed, the development, the production and operation of an use of an aircraft. So the use of the trigonometry in aviation. So before the pilot before taking off, they will ask for the heading or a vector known as a course of flown by an aircraft itself. So the vector includes the vector quantity, which is represent the magnitude and the direction of the aircraft itself. So and then this aircraft, the speed and the direction will combine and indicate the velocity. And then also the vector addition is what they call the math used to compute the product as two forces applied to an object simultaneously. And this vector addition also is used for wind connection problems. And the results also depends on the velocity as well as the wind vector, the movement of the wind vector. Oftentimes, pilot will correct wind problems graphically, but it also can be computed more easily by using trigonometry.
So the next question for me to you is what calculated that used in aviation?
So when taking off, they use the degree of between the heading and the direction of the wing along the airspeed, the wind speed, and it is also used widely the cosine rule to determine the ground speed. They calculate the positive answer from the applied quadratic equation. This is your ground, and that is your ground speed when the positive answer. Once they find the ground speed, they use the sine rule to calculate the degrees that is needed to be added to the heading to get across the ground. So that's basically for the example of calculation, they use the law of cosine and law of sine. And okay, this I'll add up. Why does it matters for the trigonometry in the application of aviation? So as we can see, when approaching an airport, pilot must learn to maneuver their aircraft. So the way of how they are piloting the aircraft itself. So visually, there is also a stabilized approach to the runway, can be flown at a constant approach angle. So precise approach planning, it also ensures a smooth transition to landing within the touchdown zone on the runway itself. So pilot must be sometimes execute visual approaches that are very in size, shape and angle based upon a velocity of factors such as other aircraft. And they also provide for the obstruction, the noise problem within the aircraft, or prevailing weather conditions. As we know, like pilot always have the problem within the weather condition, whether it's sunny or rain. And lastly, this also same applies to the takeoff. So it is really important on every part of aviation itself. Right, that's all for me.
Okay, so thank you for giving me the opportunity to interview you.
Right.
So I hope the people outside can gain their knowledge about the trigonometry in aviation.
Alright,
So thank you, sir.
Thank
Captain.
you. Thank you.
Now we want to know how trigonometry is applied in astronomy. So now we have a guest that can explain it. So we have a guest that is Professor ZUHAIRI. So come, let's go. Follow me. Assalamualaikum, Prof.
Waalaikumsalam.
Okay, now I want to interview you. What is function of trigonometry in astronomy?
Yeah, firstly you must know what is the astronomy mean.
Oh yes.
Astronomy is a branch of science that deals with the celestial objects, space and the universe as a whole. So trigonometry is widely used in the field of astronomy. Like you say, I will answer it.
Okay.
In astronomy, trigonometry is often used to find the distance to nearby stars and other celestial objects using a method of parallels. Do you know method of parallel? What is this?
No, I don't know because I don't study astronomy.
Yeah, I will give to you the answer.
Okay.
Parallel is the apparent shift of a nearby star against the fixed background that can be noticed as the Earth's orbitals the suns. So, though the astronomy has been in existence for thousands of years, it is only resilient that trigonometry and astronomy have been paired up, and since then astronomers are not able to do without it. So, like example, the astronomer used trigonometry to find the distance from Venus to the Sun. So the astronomers use the Earth, Sun and Venus and form a triangle by it. So the astronomer find the angle and the distance between the Earth and Sun. To solve this problem, astronomers used trigo. It was determined the distance from the Venus to Sun is about 105,000 kilometers.
Wow, so far away.
Yeah. So what Ada question?
So I think I don't have a question because you have give me so many input that I can't think because you are so
Yeah, yeah.
smarter than
Yeah,
me.
I know about that.
So I think that's all for the interview. Thanks for your cooperation.
Okay, thank you.
Assalamualaikum warahmatullahi. So today I'm HADDID Daniel. So as we know, trigonometry is widely used in engineering stuff. So today we're gonna interview an engineer, a powerful Dr. Prof. IR REDZUAN Sheikh, and we will interview him today for in-depth about the trigonometry application in engineering. So let's start. Assalamualaikum, Prof.
Waalaikumsalam. How are you?
How are you?
Yeah, I'm fine. Thank you.
All right, I'm so fine. So today we have an interview for you today. So as we know, trigonometry is used widely in engineering.
Yes.
So what do you think about what it is actually the trigonometry application in engineering?
Oh, wow. For first, I thank you for inviting me to the interview. And first, engineering is a medium that can use to measure many things, like measure things that we can measure, such as this roof from the ground. From your opinion, how do you measure this height?
I think we will use some sort of triangle, or maybe we have some angle to look at, and then we can predict the height of.
Okay, yes. This is also part of the trigonometry. So now I want to explain about it. Some objects and distance in our world are very difficult, even impossible to directly measure by hand or with tool, such as from the rooftop and from the ground. Engineers will design different types of structures, either incredibly large or very small, or machines which might travel distance deep under the sea, or far into space must have an accurate understanding of length and dimensions, even when they cannot be measured, so that it can go smoothly without any error. So often in this case, engineers use trigonometric and other mathematical relationship to find very close approximates to length and dimension. So that's about why engineering
Trigonometry is used.
yes in measuring.
So if we take a look at very high buildings like KLCC and
Yes.
Burj Khalifa or something, the skyscrapers, incredible engineering out there. So what we actually engineering do to maintain the high building from falling, and is it involve trigonometry?
Yes, it also involves trigonometry. So that in the design of the large structure, engineers must ensure that force acting on the structure will balance, so that it will remain stationary. Engineer use trigo to account for vertical and horizontal components of the different force that act on the structures, thus determining that the structure will be able to stand without collapsing before it is even constructed. This strategy, based on mathematical knowledge, enable engineers to design solutions to problems that might otherwise be unsolvable. So I think in building the structures, we also use trigono so that we can know what force is acting on the building, so that it will not fall down when we construct, and will give safety for the constructor.
Oh wow! So that's a new knowledge for me. So I think that's it for today. So
Yeah.
I want to thank you for spending time with us today, and yeah,
Thank you.
thank you for your.
Okay.
Thank you to the Sri Pentas. So today I'll be interviewing Professor HADDID, a game developer. So come with me. As you can see there, it's a game developer from Google Tech. So Bulletin. Hi, good morning, sir. Sir HADDID. Oh my God. Good morning. It's okay. I'll take it for you.
Oh, it's okay. It's okay.
Alright. So today, I want to interview you about game developer in application of trigonometry. So, may I sit?
Yeah, please.
Today, thank you, sir, for agreeing with me to interview you as a game developer. So, can you explain to me what is game programming?
Okay, Mr. Azizul, our interviewer for today. So game developing is actually the preparation of making the game itself. Before we publish the game, so we have to develop the game, we have to arrange the movements of the objects in the games itself. So basically, yeah. Excuse me. Okay, so basically in our game developing, so it is important for you to make a preparation for making a game.
I see.
So trigonometry is also used and basically extensively used in order to make good movements in a game. So trigonometry is used for making the movements of the object itself and also designing the characters in the games.
Oh, okay, I understand.
Okay, so basically when we programming a game, so we need to know the positions of the object itself and where of the objects will go.
Alright.
And it is also important for us to calculate the speed of the movement of the objects, and we have to know the x and y axis of the coordinates of the objects will be after the movement. So so finding the positions of the objects is involved the trigonometry. So so as an example, when we see a movement of objects, so if you can see here, if I give you an example of a spaceship,
Alright,
let's say we want to make a spaceship game.
It's like Star Wars or something like
Yeah,
that.
Star
Alright,
Wars
cool.
or something that involves spaceship. So let's say you have a spaceship here. Let's say you have a spaceship here. So you want to make the spaceship moves in a circle. Okay. So let's say you want to move the spaceship on this X. So if you can see right here, there's a coordinate here.
Alright.
And then you can see from the axis of the rotation itself, we can make a triangle.
And now we can
yeah.
It's a trigonometry.
Yeah,
It's
we
used
have to-
widely in game developing. Alright,
Yes.
cool.
So this is when trigonometry is used, when we have to find the angle of the rotation.
Alright.
As we know the radius, right?
Yes.
We know how big is the rotation it will be, and then yeah, we have to know the coordinates here by knowing the angles and some stuff, so that we can make the spaceship move to the points.
Alright.
Okay, and also in a games, example that are easy to understand is when you want to design the characters in the game itself. So as an example, we have a spaceship right here. Let's say this spaceship looks like this.
Alright.
So in order to make all the games, in order to make the spaceship looks the same through all the gameplay.
Alright, the gameplay.
through
Alright,
the
cool.
gameplay. So we have to know exact angle of every part of the spaceship itself.
Alright, okay.
So this is where the trigonometry also important.
Play an important role for this spaceship developing.
Yes,
Alright.
yeah, in the game development overall.
Okay, cool.
Okay, do you have any question?
I think so. That's all. I think I got a really great opportunity to talk with you and interview with you. So thank you so much for you to spend time with me. Alright,
Okay.
Thank you.
Thank you for coming.
That's all for the special recording on how Trigo is related to our real life. So it can be concluded that most of the modern structure and that stand still Nowadays, it's all because of the application of trigonometry in real life. Without trigo, one of these buildings can be constructed. Not just that, trigo also take part in one of our daily life activities. For example, trigo can be applied in music industry to produce best music. Astronomers and engineers also can use trigo to calculate the value of length that can be measured normally, such as the distance between two stars and the height of a skyscraper. From this, we can see that how important trigo in our life. Without trigo, we can achieve modernization that we have right now. So, back to the studio.
That's all for the special recording for trigonometry. I'm Ahmad Nick.
And I'm Ahmad Azlan.
That's all for today. Thank you.